Right, question 2. Particle moves along a horizontal straight line at time t seconds. Velocity of the particle is this here. Okay, find the value of t when the particle is at rest. Okay, so you've got v here equals that. Now at rest, of course, v will equal 0, won't it? Okay, so it might stop just for a moment, but when it does stop, when it is at rest, v is equal to 0. So we can put that expression equals to 0. Okay, and now if we've got that equals to 0, the top has to equal 0 as well, doesn't it? So t squared minus 4 is 0. So t squared will equal 4, which means t will equal plus or minus the square root of 4 when you want square root. Now that would be plus or minus 2. Okay, now you can't have t equals minus 2 is impossible. Can't have negative time. So t will equal 2, okay, when at rest. Okay, so it's only at rest once, right? And then it sort of keeps going, okay? So what we could do here, I mean, just to think about this here, when this particle is moving, okay? So at the start, maybe it starts, it doesn't say where it starts, but suppose it starts at this point here, A, okay? Maybe it's going in this direction, okay? And then when t equals 2, it comes to a stop, okay? So maybe maybe it just goes through A, and it starts to slow down, and then it stops here when t equals 2. Now you might wonder then what happens to it after t equals 2. What often happens in these questions, of course, is that it's slowing down, comes to a stop, and then goes backwards, okay? You know, that can sometimes happen. Right? It doesn't say here in this question, it doesn't really matter, okay? But the point is that t equals 2, the velocity is actually 0, we've proved that. So what is possibly happening is that it was going in one direction, okay? It was going in one direction, where perhaps the velocity was positive, okay? And then it came, you know, maybe it was reducing down until it got to 0, and then maybe it's going backwards then, okay? And it'll keep going, okay? It'll keep going then, because it doesn't stop again, doesn't it? It only stops when t equals 2. It doesn't stop again. It just keeps going, okay? Right? There are situations where it would be at rest in 2 places, okay? So you want to think about that when if it was at rest, if it came at rest for a different time then, okay? Maybe we're going back on itself and it got at rest, and then maybe it would switch directions again, okay? That's something to think about. But in this case here, it's only at rest when t equals 2. It comes to, you know, it's going along here, it comes to a stop, and then t equals 2, and then possibly going the other way up, and it'll keep going, it won't stop again. Anyway, so back to part B. This is calculate the distance travelled by the particle between t equals 2 and t equals 5. Now the reason why I went through all of that explanation just a moment ago is because they want the distance between t equals 2 and t equals 5, okay? And that's really important. There's really important concepts here to consider, all right? Because they want the distance, right? They don't want the displacement at these particular times. They're not really interested in that. They want the distance travelled between these 2 times. And what's really recognisable now and important from part A is to realise that actually between these times, the particle is just going in one direction, okay, which is really good for us, you know, because it comes to rest actually when t is 2. So they're interested in how far does it travel between t equals 2 and t equals 5, okay? So I don't know where t equals 5, it could be here, okay, it could be over here somewhere, it doesn't really matter, but they want that distance, okay? They want that distance. And the good thing is, as I said, it's at rest at the start of our time interval, and we know it's going to keep going in one direction up until t equals 5. So we're going to work out that, we can work out that distance there. And all you've got to do is work out work out the displacement when t equals 2 and t equals 5, and then we can look at the difference between the displacements those times. Okay, so to get s, of course, we need to think about v again, going back to that, rewrite that as the derivative of, okay, so I'll write it down here, write that as the derivative of s, v is the derivative of s, separate the variables, okay, So get the t's on one side, integrate this here, so that becomes s, doesn't it? Now here when you integrate this, there's a bit of work to do. If you just think about it here, it's not that difficult. Just think every term on the top is dividing by 3t, so that's divided by 3t, that's divided by 3t. What we can do is split this fraction up. Okay, and once you split the fraction up, there's nothing wrong with that, okay, because you're dividing each term by 3t. What we can do then is simplify it. Another thing I might do as well is take out a third, because you can see that there's the third as a factor, okay, and t squared over t is just t, and then you're left with 4 over t then, okay, which is quite nice. Integrate this, 1/3 t squared, and of course when it's over t, that's ln, isn't it? So it's minus 4 ln t, and then of course your plus c at the end, your constant. Now when it comes to working out your constant, okay, sometimes you can't, okay, because I know in this question, if you look at it, there's no information there. They don't say like when t is 0, s is whatever. They don't say anything like that. There's no boundary conditions at all, so we can't really work out c. And it actually doesn't matter, okay? It doesn't matter because we don't want it. It's not asking for an expression for displacement. They're not asking that, right? They're just asking for the distance. So what we'll do now is we'll work out, okay, the value of s when t equals 2, okay? S will equal 1/3 2 squared minus 4 ln 2 plus c. Okay, so we'll work that out. Okay, so get my calculator. 1/3 2 squared is 4, isn't it? Minus 4 ln 2. Okay, so that'll be 0.409137 plus c. Okay, so write down good few decimal places there, plus c, and then when t equals 5, s will equal 1/3 5 squared minus 4 ln 5 plus c, so s will equal, so I'll just go back and I'll change that there, change that to a 5, I'll change that, 5 squared is 25, isn't it? So I'll do that, and I got 6.187416. So then to get the distance then, you just got to take away 6.187 blah blah blah, take away 0.4091, etc. So take away 0.409137, that's what I wrote down, and you get 5 point, and it says 3 significant figures in the question, right? So 5 point, what have we got here? 5.7, and of course I'd have to round that up with nice with 9. So, oh, what am I talking about? 5.778, isn't it? That's what it is, isn't it? Because you've got three significant figures are the 5, 7, 7, and because that's an 8, you round that up to an 8. So 5.78 meters, that's the distance that's travelled. Okay.